All righty, are we good to go? Welcome, everyone. Good afternoon. My name is Tara Ramsey. I'm the Outreach Project Manager for Nova Education, and we are super excited for this Nova Education virtual field trip. I think this one's going to be a real treat. We are going to get a virtual tour of the Computer History Museum in Silicon Valley. So on May 15th, Nova premiered a film called Secrets in Your Data. And really, the film is a quest to find out what happens to all of our personal data that we share online. So when we're online, whether you're on social media or just surfing the web, we're often sharing a lot more about ourselves than we think, and that can pose a risk to our personal privacy or even security. But at the same time, big data sets could lead to huge advantages and advances in fields like medicine. So the film explores ways to maintain our digital privacy while enjoying the benefits of our collective data. And the film starts out in the Computer History Museum to kind of set the scene for how data has been collected over time, even before the dawn of the internet as we know it today. And that brings me to our tour today. Marc Weber is here to give us a private tour of the Computer History Museum's permanent exhibit, Revolution: 2,000 Years of Computing. Marc is the curatorial director of the Computer History Museum's Internet History program. He established web history as a topic starting in 1995 with the help from Sir Tim Berners-Lee and other online pioneers. He also co-founded two of the first organizations in the field. He's developed many of the Computer History Museum's galleries and exhibits on connected topics, including mobile, web, and networking galleries for the permanent exhibition Revolution that we are going to get to see today. Marc, hello. Thank you so much for joining us. Can you let me know when you're on, Marc? All righty. Hello.
Can you hear me?
I can hear you. I can hear you and I can see you. Fantastic. Before we get going, just a quick reminder before we jump into our audience. If you have any questions for Marc, we will be doing Q&A section at the end, so please drop your questions. If you're on Zoom webinar, drop your questions in the Zoom chat. If you're joining us via YouTube or Facebook, please drop your questions in the comment section, and we will get to as many questions as we can get to at the end. So without any further ado, Marc, I'll let you begin our tour.
Great. Well, first I just want to say welcome to the Computer History Museum, and it's really a pleasure to show you around. So data, which is, we're doing the data tour of Revolution, goes way, way back, really to the dawn of writing and calculating. And in fact, our first gallery is calculating machines, and the icon is the abacus that you see behind me here. And the abacus itself is not that old, but the kind of counters used on it go back to ancient Mesopotamia, other places in the very ancient world. And in fact, the word counter today comes from the little counters people used to use for calculation. So this is to do transactions. The other part, which I'll show you later, is writing itself came out of ways of authenticating, of having a contract, proving that you had a contract with somebody. So this is the abacus, and we're now going to jump ahead quite a ways to the 18th century, about 300 years ago. So follow me as we go down into the punched card gallery.
All right. And Marc, the abacus, what time frame are we talking about for the abacus? Was that a couple thousand years ago, a couple hundred years ago?
The abacus in its modern form, I believe, is a couple of thousand. But again, things like the abacus were used in a number of cultures. And the counters, the idea of using little tokens or counters for calculations, dates back certainly 5,000 years, if not more. There's some evidence of even earlier use. So now this is calculating machines. Sorry, we just did calculating machines. This is punched cards. And this story really starts with semi-automated looms for weaving cloth.
Oh, wow.
And this example, this is these are Jacquard cards, and the little holes in there, when they're fed through the loom, can actually produce a beautiful pattern. So if we come over here, this is cloth that was woven from a Jacquard pattern. So little metal fingers feel the holes in the cards and control the loom. This was a standard way to control machines for really until about 30, 40 years ago. But cards like that cannot be separated and sorted. It's just one long program. You get that particular cloth, from start to finish. So about 120 years ago now, and we're going to move, it's a little bit tough to move around to this. This is a Hollerith machine. So Herman Hollerith created this machine as a way to solve the problem of how to do the US Census in 1890. There was a competition for who could do it quicker, and who could create a way to do it quicker. And you take cards like those loom cards, chop them up, separate them, and you sort them. And this is the foundation of databases today and of tracking people's personal data. So each card would have things like your name, your age, your gender, race, where you live, occupation, things like that. So a lot of the same kind of personal data that you'll see today. I mean, there's an example. It's too small to see, but of what the census takers would fill out. And punched cards became the basis for office automation for really 50 years, 60 years before the computer started to come in. So we now associate them with computers, but they had a whole independent life before the computer. These are some of the sorters, collating machines that would have been used to do the data processing pre-computer.
And previously, Mark, were they punched by hand? Were these kind of handmade cards?
Well, the initial key punch entry would be by hand, yes. So somebody, everything had to be transferred from something written on paper, like a response to a census set of questions, and then punched into cards. But once they were punched, they could be duplicated. So often they would be duplicated and resorted multiple times to get different kind of information. So this behind me, and you can look at, well, like here's an example of a key punch. So somebody would use this machine to punch cards. And you have you can see that picture against the back. That's an office at the time. This is how they did the Social Security program in the United States starting in the 1930s. And where you're paying retirement benefits to millions of people, huge amount of calculation. To do it without this kind of automation would have been very difficult. And Social Security brought in, of course, the Social Security number, which is a unique identifier for a person. There have been things sort of like that before, but it really kind of institutionalized this idea. And that, of course, has both good and bad uses, that kind of unique identifier. So let's now move on to early computing.
Great.
And of course, punch cards were used, almost anything computers are used for today by companies. And they were used in combination with index cards, which people wrote. So you have these kind of, like library card catalogs, which probably very few of our audience would actually be old enough to remember, but used to deal with cards this big in a library.
Nice.
So that whole there's a book called Paper Machines about that world. Anyway, we now come to the computer. So starting in the 1940s, you have digital computers. This is the Joniac, named after one of the architects of the computer, John von Neumann. And a computer like this could substitute for many, many sets of punch card equipment, although it would still often use punch cards as input and produce them as output. But it could also do lots of complicated mathematics, and it was really general purpose in a way that punch card equipment certainly was not. And then another key element of data is encryption. So this is an Enigma machine from the 1930s, and these were most famous in the Second World War. They were commercial products in Germany in the 30s, but then they were adapted for the German military. And this lets you type something, and then it becomes encrypted depending on how you set those wheels. So this is a physical machine to do encryption. And if you watch Nova's excellent documentary, Secrets in Your Data, you learn more about the way people use encryption in the real world around data today. So we're now going to move on to real-time computing. And remember that everything I've shown you so far is what was called batch processing, where you give a machine a job to do and come back for the results. It's like a washing machine. You give it a job and come back when it's done, at least for early computers. Now we go to the beginning of real-time computers where you interact with them live, the way we do today. And this terminal is from the same nuclear warning system. This was an enormous system designed to track Soviet bombers coming over North America. So you see that the operator would have this light gun, ashtray, telephone to call if they saw something. And so keep in your mind this terminal. First, interactive terminal with a screen, pointing device. And then look at this building, not a very friendly place to work.
Is it entirely concrete, this building?
Yep.
Wow.
Concrete and no windows. And there were 23 centers around North America, not all quite as big as this, but many. But now we can look inside the building. This is a model from the time. And if you see those little terminals up there, each one of them is the giant thing we just saw. There are dozens of them on the top floor with operators. And underneath, you have all the computers to support it. And they were networked together, the centers. So it was one of really the first form of networking that we can point to clearly, even though they were special purpose computers. Networking in general was still a new idea. So that's the beginning of real-time computing. And as we'll see, this started military, but it did get applied commercially and to things closer to our everyday data. We're going to just stop because it's fun. This is the lunar lander computer. So a computer like this was used to land on the moon. Buzz Aldrin and Neil Armstrong used it for their descent. And this right here is the guidance computer from an intercontinental ballistic missile, a nuclear missile. So this is a very important milestone in autonomous vehicles, which really have a military history long before they went into cars. And then I can squeeze around. We have an IBM 360, which became the standard look of a mainframe computer in the 1960s. And these, of course, were used for data processing, whether it's your payroll or Social Security or all of the things that companies and governments use computers for. These were not personal computers, although they started to get shared with terminals with ordinary users. But that's another story. I do want to show you the first hard disk. So this is RAMAC from 1956. This holds about 5 megabytes, which is similar to an iTunes song today. But that's a lot of punch cards. And a key feature is you could search the whole disk for something the way you do now, instead of having to go through a whole bunch of cards. And then to step even further back into the history of memory and storage, this is a quipu from the Inca Empire over 500 years ago. And these were a way to track, to do accounting. So the knots, the pattern of knots,
Wow.
codes the numerical information. And for instance, the tax collectors in the Inca Empire would come out in the field with, a bunch of these over their shoulder to calculate how much you owed, usually paid in corn or some, not necessarily in money. Here's a picture of an Incan official, Tipu. Tally sticks were a way to track a contract. So you would have a stick, and two people, they'd make marks, and then you tear the stick apart down the middle, and it's a unique identifier. Only the person with the other half of that stick is the one you're in the contract with. So it's another example of authentication. So if you remember SAGE, which was the military real-time system for nuclear bombers, but led to a system called SABRE. And this is an airline reservation system. The picture here is right before it went to computers. This is still telegrams and telephone and that sort of thing. But SABRE, which was SAGE was semi-automated ground environment. SABRE became, I'm sure I won't even try to remember exactly. Anyway, it was a spin-off of that, but this still exists in back of Expedia, apparently. I mean, this is a really powerful way to find out if you want to take a flight, are there seats on this flight at that time? That was not at all easy to do before real-time computers. So SABRE became this really game changer for airlines. And there seems to be an aviation theme here, whether it's bombers or passenger planes. Mm-hmm. So we're just going to walk through supercomputers, and over on the left is actually a connection machine. It was Brewster Kahle, who coined the term big data, was one of the architects of that. And supercomputing and artificial intelligence, of course, are very, very connected with data and very big data.
What exactly is a supercomputer? Would you mind explaining that, Mark?
Well, sure. It's really just, the name is pretty much it. It's like the computer of the time that is a lot more powerful. And there are stricter definitions, but they're usually used for research, for modeling, let's say, nuclear physics or things like that. So just the biggest, most powerful computers of their time. So this is the mini computer gallery. And minis were smaller than the mainframes we just saw, but still mostly bigger than today. We started out of Digital Equipment Corporation, and actually, sorry, let me just point to the DEC PDP-8 is the machine that made that company successful, and this museum started within it. And actually, the main architect of this, Gordon Bell, just passed away, our co-founder. I want to acknowledge. And mini computers, one of the more fun examples, this is the Honeywell kitchen computer. It's not clear if any were sold. Some people say one or two. But Neiman Marcus had a catalog in 1969 where you could buy this kitchen computer or a baby elephant. Just crazy, wild gifts. So it was not clear how you would use it. It didn't have a screen or a keyboard, although they offered an apron and a programming course. The copy is very condescending. Seems like they're trying to insult the potential customer. But it sort of had this Jetson futuristic vision of computers in the home, which was quite rare at the time.
Totally.
And then this is our only gallery where the icon is not a thing, but an idea. So this is digital logic about chips and how computers work. But the icon here is Moore's law. And that's just the idea that computer components, both memory and processors, get exponentially faster and cheaper. And that's what's let us live with computers constantly the way we do today. There would still be computers without Moore's law, but they would be rare and expensive, more like the early days. So this is what powers Silicon Valley.
Are those semiconductors, or what are those mirror-like chips that we see?
Yeah, so these are, and this is showing the evolution from early ones, 1962, are the size of a coin, right? So this is cut, it's a wafer cut from a long ingot. Today, they're even bigger than this. This is from when we did this exhibit, which is now over 10 years ago.
Okay, gotcha. I would have thought, for some reason, I would have thought the small ones would be today, since our devices.
But I'm sorry. Each one of these wafers is cut into lots of chips.
Okay, gotcha. Yeah, it's hard to tell, but yeah.
So I mean, this is where they produce it initially, and then it's chopped up into tiny, they can range in size, but smaller than a penny, the actual chips usually.
Wow.
And online, by the way, there is almost everything I'm showing you is there, and you can go into greater detail on anything that catches your interest. We have certainly more explanation of chip making, which is a very counterintuitive thing. Shaky, one of the first autonomous robots, and a big inspiration for self-driving cars. And so I think we'll mostly go pretty quickly through.
Sure. We've got some questions coming in steadily from the audience, Mark. Would you, while we're transitioning into the next space, let's see, we've got a question we've got one from Pearson Elementary School in Connecticut. They're asking when was the internet invented and how did that change computers? I know you definitely know a lot about that.
Well, the internet itself, what's called the internet, is really 1973 or 4. But networks, as we saw, go back to Sage in the 50s, early 60s, and the ARPANET, which fed into the internet, is also in the middle of those. Let me just make a very brief stop because it's fun. This is the first virtual reality headset, 1968.
Wow.
So the idea, virtual reality has been trying to break into the mainstream for a long time. This is a cabinet of curiosities. We have a replica of the first mouse over here. We have the actual first mouse we just collected from SRI.
Wow.
And I'm not going to show you, they're fascinating, but I don't think they're that relevant to data. We've got the graphics gallery here, and we've got the games gallery here, which is great fun if you come. We have 3 emulated games. Here's Pong, is the icon. I think in the documentary, I played Dr. Alok Patel on a different game. This is the personal computers gallery, and there's an Apple I over there, some of the very early ones. The key thing here is that personal computers actually kind of pushed away from collecting data because suddenly computers became individual again. So computers have gradually gotten connected, and it's easier to gather data. The personal computer revolution, everyone got their own computer, and they basically didn't connect to anything. They would only exchange disks. So in a way, for the history of data, it's kind of a dark age. But then we get to the web era and the rise of mobile. And we'll look at mobile first. The icon here is the Palm Pilot. And what I really want to show you, though, is so early on, like if you look at that model, that is a mainframe computer inside a semi-trailer, a truck.
Wow. Okay.
So that's a model of a real thing. That was a portable computer in 1959. And up above is a 100-pound portable computer, an ad for one. So the reality was pretty big and heavy. But people were thinking ahead. So this model it's a mock-up of what Alan Kay called a Dynabook. And this is kind of the grandparent of both the tablet and the laptop. So you have a keyboard, you have a flat screen. He had the idea would be wireless, you would have a stylus. But this is not the original mock-up, which is lost. So this is a mock-up of a mock-up, which we think makes it real. But you can interpret it as you wish. But that idea really influenced people's development of actual computers. This is one of our simplest interactives. You can pick up a 23.5-pound, or roughly 10 or 11 kilo Osborne, one of the first luggable computers.
Wow. Was that kind of the first laptop, would you say?
Well, it would hurt your lap if you put it on your
that's
lap.
true.
More for a table.
Prototype, yeah.
And of course, handhelds came out of a calculator, where you have keys and a screen and a processor. But the story for data really begins when we get connected. So this is a section on the evolution of the smartphone. The Simon up there was the first. First, by the way, I shouldn't even use. We really say very early, because first can be hard to prove. It's an extremely early smartphone. So 1993, it had a soft, no physical keys, just like an iPhone or an Android. You would tap with your finger or a stylus. And it had, lots of the features. But it was $900. It's huge, as you can see. And you could only talk for 30 minutes before the battery ran out. So many times you see this kind of too big, early, heavy, and then it gets improved. So, go on, Tara.
Oh, no, I was just going to ask, with that first smartphone, could it only just make calls, or what was smart about it?
Oh, no, I mean, you could send email, you
wow.
had an organizer, you could send faxes, actually.
Wow.
It was just a little bit too early for a web browser, but one about a year later did have a web browser. So no, I mean, a smartphone in the modern sense, but just a little bit too early for its time. But for data, the importance of phones, of course, is they are connected. So just by being, even the phone part, you know often where someone's been, based on which tower they're connecting to, who they called, how long they stayed on the phone, that sort of thing. And when you add in all the other smart features, you get more and more data. Essentially the person is paying for their own tracking device. So it just changed the amount of data that we're sort of producing and that can be collected. And where does that data go from the phone or the user? So this is the networking in the web gallery. Two galleries combined. And the icon is this Google server rack, a very early one from Google. This is, one of the key components of what we call the cloud. Big centralized servers that you connect to from your web browser and later from a mobile web browser. And this is where the data essentially goes and is crunched and reused. That logo is Google's early, when it was called Backrub, early logo. And so I did want to, I think I mentioned early on the clay tablet. So that is kind of, we have it here because clay tablets would refer to other clay tablets, a cross-reference. And cross-references are the basis of encyclopedias here, and libraries, and really, the scientific revolution, religious texts, which will refer to other texts. So it's really the key way we organize information. But clay tablets started around transactions. So they were originally clay, there's one theory, there are a number of theories. They were pouches around little tokens indicating like you had borrowed X amount of jars of olive oil or owed someone that would be a proof of the debt. And that those symbols gradually evolved into writing. So whether that's exactly the right theory, there's a deep connection between data, writing, and calculating machines. So this is about the birth of the web.
Where's that clay tablet from, Mark?
This is from the Rosicrucian Museum in San Jose. It's a reproduction.
Okay.
But
is
it's
it
a
from
reproduction
like the Mediterranean area or
of a Mesopotamian medical tablet.
Okay, wow. Awesome.
And they're actually, you can learn to write cuneiform online with a piece of soft clay and a stylus. It's kind of a fun technique. And then, so we'll come back to the web part. Or maybe, yeah, we'll do the circle. So the networks, of course, start in the electronic form with a telegraph. This is our telegraph interactive. The world was wired at the speed of light by the 1870s, but it was extremely expensive. So this was mostly used for transactions, for financial things, for governments, for news. It was not within reach of the ordinary person. So in one way, you can look at the whole story of computing as it getting cheaper to move data around. This is the beginning of computer networking, and ARPANET IMP, and an NPL from England, the NPL Mark I. This went on your terminal. So very early networks, and after SAGE, but still early. And then this, we have the real van outside, but this is a model of the van where the internet was born.
Okay.
And John, if you can zoom in on the telephone she's on. So, can you guys see that's a Mickey Mouse phone?
Oh, wow. It's hard to see, but we can see kind of the truck and the models. We can see she's on a phone. But yeah, wow, it's a Mickey Mouse phone.
And that's based on a real photograph, because this van was built for packet radio, which is for mobile. It's like the grandparent of every mobile network, Wi-Fi, your phone, et cetera, as well as voice over IP, like Skype, or like what we're doing right now on Zoom. And also, it was used to test the early internet, because the internet is a way to connect networks together. And they did a test around the world over the satellite network, the packet radio network, and the ARPANET, the wired network.
Okay. Yeah, we have a great question from one of our viewers who asked kind of what you're explaining, but how did computers talk to each other before Wi-Fi? Was it all wiring? Was it telegram? Like how did these networks communicate?
Well, so initially they just used the existing telephone and telegraph system.
Okay.
So that's why wired networks actually got bigger earlier than radio networks, because you had this whole infrastructure. And actually, I think, let me show it since it's so relevant. These are early bits of telecommunications equipment. Like this is a teletype designed for telegrams, nothing to do with computers. These were repurposed by early computers. Paper tape, which is the way they read programs, was developed for the telegraph. Modems let you send computer data over voice telephone lines. And okay, I'll torment your viewers with, that's modem noise. So it was all about repurposing telecommunications equipment for computers. What I showed you before, the ARPANET, the internet, is about making dedicated networks just for computers that are more efficient for computers. So it's definitely two steps. Wi-Fi and wireless, it really depended on another 20, 30 years of developing networks, data networks that were wireless and cell phone networks. So it took longer, even though the work started at the same time. The late 60s, they both started working on wireless and wired networks for computers. So we did this. Let's see. This was kind of fun in the 1980s in Berkeley, and there were earlier versions in the 70s. You could walk into a record store, a cafe, and type messages of all kinds, the community memory terminals. And it would cost money to write, but you could read for free. There's been this sort of split between reading and writing online often. And in fact, this is the web browser family tree. So we start with the very first web browser was also an editor, 1990 at CERN in Geneva, big physics laboratory. And the whole idea was that it was participatory, that you would be constantly writing as well as reading, and your own computer could serve up pages to other people. So a very decentralized, participatory model, a little bit like the personal computers that were still common. But they didn't fund doing that on popular computers. It was done on a very special one. And they called for volunteers, and you got volunteers writing some wonderful browsers, but adding the editing was technically a lot of work, so they left it out. And basically the web became much more about browsing than authoring. And that is, to some extent, what produced larger amounts of data for the following reason. So in the beginning, they did track like who visited a website, who they were, where they came from. So basic demographic data about who's visiting. But there was not generally one big central places to collate and compare all that data like the later cloud, like I showed you the Google server rack. So because you couldn't write on your own browser, they developed ways to let you write on the server, like Google Docs, like early blogging platforms, social media. So you could write, but only connected to somebody else's big server, the cloud. And what powers it all is advertising as a business model. So the web we think of today as being very commercial, but at first it was not clear at all. How would you make money from an open standard running over an academic network? So this is all about the struggle to find a way to create a business model for the web. And the solution ended up being advertising, but also contextual advertising, where it tracks data about you to show you the ads that you're likely to be interested in. And Google was one of the main pioneers, GoTo, and that's really become the model, which I think the Nova documentary talks about. Here's a complaint about spam from 1864 on the Telegraph.
Oh,
Somebody
wow.
writing to the Times of London.
Wow.
Anyway, web commerce and, sorry, go on.
Oh, I was just going to ask, do you think there could be an internet without web commerce? Like, is there some way we could have avoided all of the
Oh, sure. Because
ads?
all the earlier systems, yeah, but it comes literally at a cost to us, because almost all earlier online systems, and I kind of skipped over, there were dozens. Like in the 1980s, you could be on CompuServe, you could be on AOL, Minitel in France, huge system. There were dozens. But they didn't talk to each other, but they all charged you by the minute.
Okay.
So the model from the telephone companies way, way back up to the web was paying for access by the minute. And that meant, that you could pay a lot. Some people had huge bills, but there was not that kind of conflict of interest where they're trying to just lock you in to watching more or clicking more to serve you more ads. So they didn't care. As long as you're online, they get paid by the minute. Very different model. But it costs money. It's not free. This is Jeeves from the search engine Ask Jeeves, which was in the late 90s, mid to late 90s, based on natural language queries, like asking questions the way we do with a chatbot today. So the AI was still not quite up to doing that the way we do now. So there was a lot of human assistance on the back end. And actually, my wife worked for Ask and helped create some of those smart answers, as they called them. But the idea was very, very much like a chatbot. And one thing a lot of people don't necessarily know today is that modern generative AI was incubated within these big web companies, search companies, social companies, because they had both the business need and they had these huge data centers. They had the capacity, and that older research sort of flowered in that environment.
Wow. Awesome. Well, I think if you're ready, Mark, we've been getting some really great questions throughout the tour from our audience. If you guys do have questions, we'll take more questions. Just drop them in the chat, and we'll try to get to them by the end of our virtual field trip here. But we've got some great ones that have already come in. One person asks from Prairie Hills Elementary in Thornton, Colorado, how did the museum collect all of these computers on display, and do some of the older computers still work?
So for how we collect is basically people giving them to us. Old computers, as you may know, it's not like an art museum where you have to go out and buy these tremendously valuable things. Older computers are mostly e-waste. So even ones that are historically very important, often the institution that created them, when they get old and they're not being used, they're basically going to be dumped. So we depend on people who know their historical importance to let us know. And we also go out and look for some when we know, like when we do an exhibit, we're doing a chatbots exhibit right now. So we're actively going out and looking for things to collect to tell that story. So it's a combination of people offering and us going out and looking. And the other question was, what was it?
Do some of the old computers that we saw, like some of the early model computers, work?
Not the ones you've seen today, except for the RAMAC. The old hard disk still runs. They run it for demos. But we have two restoration rooms where we have an IBM 1401, so a 1960s kind of a mini mainframe, but the classic punch cards, and it makes noise, and if you come and visit us in person, they will punch a card just for you. And then we have a PDP-1, which was featured actually in the documentary where I play Dr. Alok Patel at Space War, the first shoot-'em-up game that we know of. That was done on that machine, and we played on the original machine. So that's a restoration that you can come in and play when there are volunteers to show it off.
Awesome. Cool. Well, we've got another question, which I love. So I was recently actually in the Computer History Museum, and I was just blown away by how big the space is and just how much there is to take in. But it really kind of does a great job of showcasing like progress and the pace of progress. We start with thousands of years, and then we get into every decade. There's so much of it. But let's see here. Someone asked, what do you think, and this is a big number, but what do you think the next 1,000 years of computing has in store for us? Or even, I would pose, the next 50 years of computing has in store for us.
Well, it's hard to predict.
Yeah, it sure is.
But I mean, because there's so many surprises, what I've called turning points, where you really can't predict. It depends on someone making a business decision that works or doesn't, or a technical breakthrough. Like generative AI was one of a dozen techniques for machine learning until fairly recently. It turned out that scaling it up with data center scale computing turns it into something really remarkable. No one could have predicted that. And there may be other surprises like that ahead. Why the web won out over a standard called Gopher, it really comes down to kind of almost chance, luck. But then you can look at some, like Moore's Law is an example where you can look ahead at a trend that, computing will get smaller, faster, cheaper. So if we take, that sort of stopped the way Gordon Moore initially formulated it, but the basic idea is true. So what happens when, really, really smart, large-scale computing just becomes absolutely ubiquitous at almost no cost? And, I personally think you end up with some of the ideas for the smart home or whatever, tracking your personal health, but I mean just kind of ubiquitous computing where it's embedded in everything. And we know from human nature, I mean, when I think about the future, I like to think of, like the genie in the stories that gives you wishes and then messes them up. So a lot of things don't turn out the way people want. You have, Moore's Law, we get super fast computers, but then it's wasted on all sorts of like adware and stuff like that. Or, is your smart toilet going to let you sit down until it's finished updating its software? I mean, try to imagine the ways things can go wrong, because that's also part of computing. Early visions are often very kind of only, taking the perfect scenario. So you have to think of, there's actually a famous science fiction writer, Frederick Pohl, who said, a good science fiction story predicts not just the automobile, but the traffic jam. So you need to think of how things can go wrong as well. And that's as far as I'll go for prediction.
No, that's a great analogy. We've got a question from Carolyn. She's asking, is the decentralized browser one of the first examples of distributed computing?
No, I mean, it's important, but the browser, that was actually client server, where you have a browser on your computer connecting to a server. Truly decentralized computing, though, does have links. So Sir Tim Berners-Lee, who wrote the first browser editor with Robert Cailliau and later with Jean-François Graph, a bunch of other very important people, Nicola Pello, Peggy Rimmer, his boss, his whole expertise was distributed computing, remote procedure calls. It's a big physics laboratory. You have to get lots of different pieces of equipment to work together over a network. So he and his boss, Peggy Rimmer, worked on distributed computing for high energy physics before he turned to the web. So there's an indirect connection there.
Okay, gotcha. All right, we've got a question from Tina. She asks, what role do you think the Computer History Museum plays in the education and inspiring of future generations?
Well, we hope that it is inspiring. I mean, we think that, knowing the past is what can help you invent the future or certainly live in the future. There's an awful lot of reinventing the wheel in computing. And often by understanding more what happened before, you can, both avoid simply going in circles, but also find, really cool new things to do by applying an old idea in a new way.
Yeah, I totally agree. I was also, when I was in the museum and just in this tour as well, I was so impressed with like solutions that people came up with, like pre-asking Google, like it's just so impressive, the like ingenuity of humans and kind of the trajectory of how we got to here today. And I can't help but feel as like a lay person, like I totally just take all of this technology for granted. And I'm just impressed at people who can dream it into existence.
Hopefully there's the future dreamers are, they're out there, and we hope that we can help them, learn some things or maybe get some inspiration.
Yeah, absolutely. All right. So we've got one final question for you, Mark. How can folks learn more about your work and the Computer History Museum in general?
So our website is computerhistory.org, and you can find the Internet History Program, which is what I run within that, as well as our programs. Almost everything you saw today is in the online version of Revolution. There's also an online version of our software exhibition, which is a whole nother topic. So, I would encourage viewers, go to our site. Also, there's an excellent documentary about data that you should watch if you haven't already, which actually goes into one of the things we would like to figure out how to educate people on is, how to be a good digital citizen, how to take care of yourself online and be a smart consumer.
Absolutely. Well, thank you for the plug. I think the documentary you're referring to is Secrets in Your Data. Marc was featured in Secrets in Your Data, and you guys can all check it out on Nova's website. Thank you so much, Marc, for educating us on the history of computing as we know it today. There's just so much in the museum. What was that?
And let me add, we also have a Roblox game and a Minecraft game, which you can find on our site. And actually, my son helped test and come up with ideas for those, but they're fun, and you learn a lot.
That's awesome. Awesome. Yeah, well, definitely check out the computerhistorymuseum.org, everyone, to dive deeper into things that we got to touch on today. There's just so much in this exhibit that you could never possibly get to it in a 45-minute tour, but this was really, really fascinating, Marc. So thank you so much for joining us. Alrighty.
Really my pleasure.
Awesome. Thank you so much. So I would like to thank everyone here, in addition to Marc. Thank you everyone for joining us. Your support makes these events possible. So thank you for joining from school, from home. Your engagement and your questions were fantastic. And without you, this virtual field trip would not have been possible. So we really we value you all, and we also value your feedback. So after this field trip, if you wouldn't mind filling out a brief survey, it really does help us to create these events and know what you guys are into and what works. So that'll pop up after the event concludes. We also couldn't do this event without our funders. Major funding for Secrets in Your Data is provided by the Corporation for Public Broadcasting. Additional funding is provided by the Alfred P. Sloan Foundation and the George D. Smith Fund Incorporated. Funding for NOVA and this program is provided by Carlyle Companies, the Nova Science Trust, with support from Margaret and Will Hurst and Roger Sant, and the Corporation for Public Broadcasting and PBS viewers. If you're interested in seeing Marc and Secrets in Your Data and learning more about what happens to your data online and ways that you can take back control of your digital privacy, you can stream Secrets in Your Data on Nova's website, on our YouTube page, or on the PBS app today. And you can follow Nova Education for more educational content and opportunities on Twitter, Facebook, and Instagram. We'll be hosting another virtual field trip around Secrets in Your Data on June 6th. So tune in to learn more. Our guest will be Matt Mitchell, the founder of Crypto Harlem, and he will be teaching us ways that we can beef up our personal data privacy online. And I think that is all for now. Thank you again to Marc and all of you for joining us. Thank you for your questions and your time. This was really just a taste of everything that's on offer at the Computer History Museum. So really definitely go check out their website. And if you can get there in person, I highly, highly recommend it. Well, thank you so much, Marc. And yes, thank you everyone for joining us.
Very well.